Hello everybody, my name is Svetlana Schleipek and I will present to you our work for the Robothon Grand Challenge. Our team Singularitas is a team of 4 robotists from Faculty of Electrical Engineering, University of Ljubljana, Slovenia, who are at the different steps of robotic education. But we are all joined with the common belief that robotics has a major positive impact on our lives. First, I would like to present our solution for taskboard. We use Universal Robot UR5E equipped with gripper handy by robotic and custom 3D printed fingers. For taskboard localization, we used ordinary Logitech webcam. We designed a graphical user interface where operator can select custom order of task, get a preview from the camera and see current status of the robot. User interface is connected with the robot via TCP/IP communication. For localization, the robot moves to higher pose for acquiring the macro position of the taskboard, and then it moves closer to it for micro-localization regarding the position of red and blue button. After the taskboard is located, the robot moves above the blue button and presses it based on force feedback. Then the robot moves to pick up the key and transfer it to the key switch. Key is used as a force probe in 2 directions to get the correct position of the keyhole. Then the key is simply inserted into the keyhole based on the force and rotated until the switch force is detected. For handling Ethernet cable, we use a small groove on one finger to press on the locking pin to release the connector. For insertion, again, force feedback is used. To open the battery cover, we press on it with a constant force and slide it open. For unhooking the batteries, we use small pins on the fingers to squeeze the 2 batteries together and at the same time unhooking them from the holder. After that, we pick up individual battery and set it upright using small magnet in the finger and gravity. For insertion, we use a spiral motion with force feedback to detect the hole and to insert the battery in place. For coin battery removal, we use pin on the finger and force feedback to unhook the battery. And at the end, the robot presses the red button based on the interaction force. Overall, our solution is based on camera recognition and force feedback for maximum robustness. The combination proved to be successful. Idea for the transferability demo came from our lives. I'm a proud parent of 2 boys, 3 and 5. My kids have very generous grandparents that get often carried away with toys and gadgets for their grandkids. But unfortunately, majority of gifts they gave have some kind of electronics embedded inside, and that electronics needs power source, mainly represented by batteries. For demo, we prepared force-based battery extraction from 2 toys, a toy robot and a toy keyboard that came as a part of a child book. We use the same principles for extraction as for the taskboard. Pins for unhooking the batteries, magnet and gravity to set them upright. For the toy robot, the transfer is quite straightforward. With the keyboards, the batteries were unfortunately switched left-right, so we could not unhook both of them at the same time, but needed to do it one by one. Overall, children electronic toys have a large potential to become future e-waste after children are tired of playing with them. Responsibility is of course on the parent side to pass the toys on to other children, or in case that the toy is damaged beyond repair, take care of proper disposal. To further minimize toys e-waste problem, children should play with the toys that come from renewable sources, such as wooden toys, or even better, to use the most powerful force that is available for free at every step at any time, their imagination.